Hi everyone. Today we're going to talk about how to graph a quadratic function in Intercept, otherwise known as factored form. The equation for the intercept form of a quadratic function is f of x equals a times quantity x minus r1 times quantity x minus r2. Notice that instead of the a, h, and k with the parentheses squared that shows vertex form, this one has an a value and then factors that can be multiplied together. The a value is going to act exactly the same as it did in the vertex form. So a positive a value will cause the quadratic function to open upward, and a negative a value will cause the quadratic function to open downward. A value with the absolute value greater than 1 will result in a vertical stretch, and an absolute value of a that is less than 1 will still result in a vertical compression. Anytime a function is written in factored form, we can set the function equal to 0, and then we'll be able to apply the zero product rule that you learned in Algebra 1. The zeros of the function will be r1 and r2. Notice that they are opposite in sign of what's in the parentheses, and this will happen because when you solve the equation, for example, x minus r1 equal to 0, you would add r1 to both sides. And if r1 were a negative number, then it would be x plus r1, and you would have to subtract r1 from both sides. That doesn't make as much sense right now. Hopefully it'll make a little more sense when you see our specific example that we do. The axis of symmetry is still going to be the same, and we still will find the domain and range the same way. One of the new words we want to add is maximum and minimum, and so you can see if the quadratic function is opening upwards, it's going to have a lowest point, and so the y value of the vertex will be a minimum value, and if the parabola is opening downwards, then the parabola is going to have a highest point, and k is going to be the maximum value. Now, how do we go about actually finding the vertex? Well, we need to use the fact that all quadratic functions are symmetric about their axis of symmetry. And so if you're more of a visual person, you could just use the graph and count halfway between the two x-intercepts. If you're more of a formula person, in order to get halfway between the two x-intercepts, we can take the average of the two. So the x-coordinate of the vertex, or the h, will be r1 plus r2, all divided by 2. And then whatever value we get, we can substitute that into the function, and that'll give us the y value of the vertex. So the information that we'll want to draw on the graph, because it's the easiest information to find, will be the zeros and the vertex. And that'll give us 3 points, and that'll give us a really good idea of what the parabola should look like. So let's do an example. We're going to graph the function f of x equals negative 1/6 times quantity x plus 2 times quantity x minus 10. I notice because of the a value of negative 1, 6, this parabola is going to open upside down, and it's going to be vertically compressed by a factor of 1/6. Next, we'll use the zero product rule to find the two zeros. And because x plus 2 and x minus 10 are the factors, I can set each of those equal to 0. So by subtracting 2 from both sides, I get x equals negative 2. And by adding 10 to both sides, I get x equals 10. Next, I can find my axis of symmetry and where the x value of the vertex is going to be. So if you like the formula, I can just add negative 2 and 10 together, which is going to be 8, and then 8 divided by 2 is going to give me 4. That means that my axis of symmetry is going to be the vertical line, x equals 4. Again, if you're more of a visual person, what I could do is I could just plot my two zeros at negative 2, 0 and at 10, 0. And then if I count evenly in between them, I see that the middle of those 2 points is on x equals 4. Now, how high or how low should the vertex be? In order to do that, we need to substitute x equals 4, the value for our axis of symmetry, into the function. So I substitute the 4 for both of the x's. And then, following order of operations, I simplify inside the parentheses first. So it'll be negative 1/6 times 6 times negative 6. And then when I'm multiplying, I need to remember that I can only multiply two things at a time. So first I'll do negative 1/6 times 6, which will be negative 1. And then I'll do negative 1 times negative 6, which will be positive 6. So, now that I know that, my vertex is 4, 6. I also know now my domain is negative infinity to positive infinity. My range, because it's an upside down quadratic function, is going to be from negative infinity to positive 6. And I also know that the maximum value is going to be 6. Notice because of the quadratic function's U-shape, it can only have either a minimum or a maximum. It will never have both. So final thing I'm going to do is I'm going to plot the vertex at 4, 6. And then finally, I can connect the dots. And let's think about our common sense. So if we go back and we look at the original function, we notice that it's upside down. So that's good, our function's upside down. It's symmetric. It has the zeros that we want it to have. And we can also see that it's a little shorter parabola because of the vertical compression. So that's how you graph a quadratic function in intercept form. First you find the zeros, then you find the middle of the two zeros to figure out the axis of symmetry and the vertex's x value, and then finally take the x value, substitute it into the function to get the y value, and then you just plot the vertex and the two zeros and use those 3 points to draw your u. So now it's time for you to go practice.